question 3. So all we just need to integrate cos of 6x. So the integral of cos is sin, so you'll have to look in the log tables for that. And then it's just the 6x. And then we have to divide then by the differential of what is inside of what's in here. So the differential of 6x is 6. And that's it. And then you have to add on c, because we're just integrating, it's not between anything. So that'll catch some people out there. You'll lose a mark if you forget the c. Right, second part, so it's the equation of the tangent to the graph of f. So I can find the slope of the tangent by just differentiating and putting in 2. So if I find f dash x, I get 6x squared minus 18x plus 5. And if I put a 2 in there, so 6 times 2 squared minus 18 times 2, so that's f dash 2 that I'm finding, plus 5, I'll get what the slope of the tangent is at the point 2. So I get minus 7 there. Now I want to get the point on the curve as well. So if I was to draw that, so this cubic will be, it comes down, I don't know, I'm just drawing randomly now, but it comes down at where it's 2. So if that's the point where it's 2, the tangent is minus 7 where it's 2. So we'll just pretend that it's there. So we know that the slope of that tangent, that straight line down, is minus 7. The slope is minus 7. I have to get that point. I have to get the point as well. I know the x coordinate is 2, but I just need to get the y coordinate. So I'm just going to put 2 into the original function. So f of 2. So that would be 2 times 2 cubed minus 9 times 2 squared plus 5 times 2 minus 11. And I should get minus 21 there. So the point is 2 minus 21. And then I'm just using the equation of a line formula then. So it's y minus y1 equals m by x minus x1. So that's y minus 21. So plus 21 is equal to minus 7 times x minus 2. So y plus 21 is equal to minus 7x plus 14. And just rearrange it around a little bit to make it a bit simpler. So 7y plus 7x plus y is equal to minus 7. And that's the equation then of that tangent. So find the coordinates of the x coordinate of the point of inflection of f. So we've already, to get the point of inflection, we're going to get the second derivative, so f dash dash x, and we're going to let it be equal to 0, and then we're going to solve for x. That's how you get the point of inflection. So 6x squared minus 18x plus 5 . So that's f dash x. I've already found that in the first part, so I don't need to differentiate it once again, but I need to do it for the second time. So I'm going to differentiate that again. So that's 12x minus 18. And what we do then is we let that be equal to 0. So 12x minus 18 is equal to 0. I'm just bringing the minus 18 across. It becomes 18 on the other side. And then I divide by 12, so that it'll give me 2 when I simplified. So x is equal to 3 over 2, and that's it. We don't need to get the y value. So most of the time when they ask you this, they'll ask you to get the actual point of inflection, but we just need to get the x coordinate of it, and we've done that. If you wanted to get the y coordinate, you'd take the 3 over 2 and put it back into the original function, this at the top again, but we don't need to. So they don't ask us here. Right, last part then. You could go and try and draw the graph of p dash x. it's going to be difficult here. So like p dash x, that's where the slope of p of the slope of the tangents of p of x. So it's hard to see really, but it's just going to be where our tangents are going to be parallel with the line L of x or L dash x in this case. So we want tangents to the curve p of x that are parallel to that. So one would be, maybe if I just bring it down to the graph there, so maybe that point. So that point there, and then the other one, so again I'll just draw it along it and try and move it around. So where would that tangent hit the graph? So it would be around there somewhere. So as long as you're showing your workings on the graph, so I'll just say it's there. So would be, my x values would be maybe 2.1 and we'll say 6 point hard to say really, we'll say 6.6.